You already know how to work with and think about data as a data analyst. Naturally, it's part of what you do every day, probably even outside of work. Not only that, I imagine you're big into data visualizations, consuming charts and graphs to glean more insights and pick up non-trivial trends. And maybe you're thinking it's time to leverage the power of these visualizations for your own work, not just to understand your data better, but to communicate it well to those who need answers from it. Hi, I'm Bill Shander, founder of Beehive Media, an information design and data visualization consultancy in Boston. Welcome to my course on data visualization for data analysts. This course is focused on the communications part of data viz, and I'm going to help you get beyond the data and think more clearly and strategically about how to present that data to an audience. We'll cover a bit about the primary challenges we face as communicators in today's world and how to begin to think about solving them. Then we'll go through 10 primary lessons, the most important things to think about when visualizing data for your audience. So you're not simply kicking charts out of Excel, Tableau, Stata, or whatever tool you're using, but rather you're really delivering the best visualization to tell the story you're trying to tell. And I'll share some examples of visualizations to make the theoretical more tangible. I hope you find the content fun and interesting and of course helpful in your day-to-day data analysis practice. Let's get started. Reaching an audience with your message has always been challenging, but today's communicator faces more challenges than ever. Most business people, analysts, consultants, scientists, people whose real job isn't communicating, often take these challenges for granted, which is why they struggle to connect with an audience when they're sharing a report during a meeting or sharing scientific data-driven results. One of these challenges is information overload. There's a famous quote from Eric Schmidt where he said that we generate more data now in 2 days than was generated from the dawn of time up until 2003. Thousands of years of data in 2 days. We're inundated with information. This is not news to anybody. And by the way, this quote is from 2010, so it's probably more like maybe every 2 hours that we create that much data now. Because of this, everyone demands to be entertained. They have to be lured into longer form content. My clients argue that they're different and that their audience is different. I would say maybe, but what's the first thing they do in a meeting? They start thumbing through a presentation if it's printed and try to jump right to the good stuff, right? Your audience may be sort of different, but really, they're mostly just like everybody else. One of the main solutions to address these challenges is something that I call the 4x4 model for knowledge content. The idea is you need to create content in layers or levels whose purpose is to guide people so they can find the right depth of content for them. I call the top level the water cooler moment. This is short form content, the attention grabber. It's images and tweets and 30-second videos. Think about it this way. One morning, we might be standing around the water cooler talking about the World Cup finals. And if there are 8 or 10 people there, 5 of them couldn't care less about the teams involved, or maybe even hate one of the teams, but they kind of like football, so they're interested in the conversation. Those 5 people might go to the cafe. They'll self-select into the conversation based on their interest in the subject. The rest go back to their desks. That's okay. They're not the audience for that content. Now, cafe content is a blog post, a short article, a 3 to 5 minute video. It gets you a bit deeper into the subject. Now, it turns out 2 of those people at the cafe, they're total football statistics nerds. They want to go to the research library, the next level down. They're the ones who will read the 100-page PDF of stats. They'll go into long-form content mode, and the rest of the people who leave after the cafe, once again, that's okay. They got the right level of content for them. Finally, we have what I call the lab. Those are the interactive data experiences, the data dashboard. The people who need the dashboard aren't satisfied with the PDF because that's still been edited. They want to play with the raw data themselves. This is a subset of the people who are open to the research library content. You can't just drop somebody into a 100-page PDF or into a dashboard without setting it up with great water cooler moments and cafe content. The second 4 in the 4x4 are those 4 key components you want to build into all of your content at all of the levels: visualization, storytelling, interactivity, and shareability. We're not here really to talk about most of those today. We're focusing on visualization, obviously, but the 4x4 model is a really good framework for how to think about creating content to get the right people to the right content at the right time. I gave a whole 20-minute talk about the 4x4 model at a conference, which you can check out if you want to hear more about it. You have to kind of think of it like dating. You know, you have to get all dolled up, right? You have to douse yourself in Old Spice or Chanel No. 5, trim or curl your mustache, or shave your legs and, really get to be the king of the disco. When you're So you want to communicate your data to an audience. Where to begin? Well, you begin at the beginning. You begin with focus. I've created a family of acronyms that are absolutely terrible, I have to warn you. But they have a shorthand that's not bad. The QUIs, which rhymes with why, which is what you constantly need to be asking, along with other questions, to really bring focus to your work. Okay, here's the first terrible acronym. It's pronounced Quirwitz. Terrible, right? Well, bad acronym or not, Quirwitz stands for Know What You Really Want to Say, and this is one of the most important ideas in this entire course. It may seem like an obvious idea, you need to know what you want to say to communicate, duh. But really, this is absolutely critical. Most of the time, we think we know what we want to say, but we don't take a step back and think deeply about it. For instance, asking ourselves questions like, is this really what I want to say? Why? What's the real point here? What do I want my audience to do with this information? Why again? Is this the right thing to be focusing on? Etc. You get the drift. Question everything, and you will do a better job really communicating what you want to communicate. This is where 99% of communications failures occur. We don't stop and ask these questions of ourselves, our colleagues, and our clients. All right. The second one is pretty simple and straightforward, especially for you, a data analyst. You need to know what your data is saying, obviously. I don't need to dwell on this one for long at all. Of course, your data is what you're talking about, so you need to understand it. But that goes beyond understanding the data technically. The implication here is also that you're looking for the right insights, aggregating and summarizing values appropriately, digging for nuanced understanding, but not so much as to blow right past insights and straight into confusing yourself or your audience, right? Finally, this one is the one that most people really don't think about enough, and that's your audience. If your audience speaks French and your presentation is in Japanese, you're not going to get through to them, are you? Of course, you need to speak the language. Expand this idea a bit, and you can understand that if you're communicating to an audience of lay people, you don't want to use too much jargon, right? You want to simplify your language, use more images and conceptual drawings, label and annotate everything so nothing is left for chance or misinterpretation, and provide the context they need to make sense of what you're sharing with them. I often talk about understanding your audience as being more about channeling them. You need to really try to embody their spirit, think how they think. Listen to yourself or read your report and try to imagine what they would be thinking if they were consuming your If you think about the beginning of language from the earliest days, the written language was all made of visuals. It was symbology. The pictures represented the actual concepts being communicated. As language evolved, as communications needs evolved, text was required so we could communicate more nuanced and abstract ideas and not take up quite so much space. But it really hasn't helped us when communicating data, numbers. You can actually parse and understand data, numbers, more quickly and easily in visual compared to text form. I don't know if you know this, but 30 to 50% of your brain is devoted to visual processing. Human beings are wired for visuals. And it takes a fraction of a second to make sense of a visual scene, meaning before you're conscious of it, you're judging visual experiences, including charts and graphs, maps, and infographics. So I'm going to go through some scientific principles about how we process visual information. It really helps to understand these principles when you think about how to visualize data. There are really 5 key concepts. They're from Gestalt psychology. They're called Gestalt principles. And the most important thing to understand about these Gestalt principles is the speed at which they occur. As I mentioned, you process visual information very quickly, subconsciously, before you're paying attention to it. The term we use is pre-attentive processing. I want you to remember this because every design and visualization decision you make based on your understanding of Gestalt principles, should be done in awareness of your audience's pre-attentive, subconscious reaction to it. This should guide your every step. So the first Gestalt principle is called figure ground, and it's used very frequently in logo design. The idea here is that human beings will always see the figure, the object in the foreground, and will also simultaneously see the background. So in the case of the FedEx logo, we see the purple and orange letters, of course, but we also simultaneously see the arrow between the E and the X. You may not always be aware of it, but your brain is wired to pick up on these things. This effect, figure ground, plays into data visualization in one way, and it's not the most important among all these Gestalt principles, but it is interesting and relevant because humans live on Earth. Earth has gravity. The mountains are down here near us, and the sky is up above. So humans will always perceive the thing on the bottom as being the object in the foreground, and the thing on top as being the background, by default. So here we have two area charts, and regardless of color, whether we're looking at the white chart on a black background on the left, or the black chart on the white background on the right, you're going to perceive the bottom part as being the data, and the top part as being the chart background. So, why does this matter? Well, it matters because I've seen people try to draw upside-down area charts for some sort of effect. And they can work. I'm not saying that you can never break the bounds of these particular rules, but the fact is most humans are automatically going to perceive it this way. So just keep that in mind. The next one is known as proximity, and this, like many of these, is pretty obvious. Human beings see things that are near each other as being together. So those three columns of dots on the left go together, the two columns on the right go together, and the two sets of columns don't go together, right? They're separate groups. Proximity is one of the most powerful Gestalt principles, one of the most powerful pre-attentive triggers. That's one reason why when you look at a scatter plot like this, you notice the dots that are all clustered near each other in the top right-hand corner, and that clustering tells you they have something to do with each other. This is what reveals patterns to us in charts like this. Next one is called similarity, also an obvious one. We see things that look similar and assume that they go together. Similarity seems to override proximity sometimes. Here we will all pre-attentively think the black dots go together and the white dots go together, but that the black and white dots don't go together. They're separate groups. Whether similarity is in shape or size or contrast or color, we can't help but see things this way. Contrast, however, is a much more powerful pre-attentive trigger than, say, shape is, just so you know. The next principle is known as parallelism. And so the idea here is that we will see parallel lines and assume that they go together or that they have something going on that's similar, and the things that aren't parallel are different. And again, this is brain science. If you asked a 4-year-old child who hasn't studied geometry yet, he'll tell you the three parallel lines go together. That's why if we look at this area chart, we can see that the shapes parallel each other in spots, so we can't help but understand that there's some sort of correlation, some sort of pattern going on between the different shapes. Lastly is the principle of common fate. I just love the title of this one. So the idea here is that you might have a bunch of things that have no discernible pattern. There's no proximity or similarity or parallelism to reveal anything to us. But once they move, we understand that some of these dots share a common fate. So I perceive them as going together, as belonging to each other. So animation and interactivity can be used in data visualization to trigger a pre-attentive response, to reveal patterns and outliers in your data. Gestalt principles drive how people perceive all visual experiences. It happens fast, and we make subconscious judgments all the time. So, as a creator of visual things, charts and graphs, we have a lot of techniques to use to draw the eye, to show changes or patterns in data. And really, it just comes down to a few key ideas. You can change the orientation or the length or thickness of a line, or the shape of something, or add little hash marks. Okay, Time for 10 easy lessons for data visualization for data analysts. This is a course for data analysts, so it may seem a little crazy to have a chapter about using the right data as though you don't know the right data to use to tell your story. But here's the thing. From my experience, often my clients who are closest to the data do struggle with this idea. The struggle comes in two primary forms. You've heard the phrase, if your only tool is a hammer, everything looks like a nail. Data people often get stuck thinking about their data as a tool in their toolbox. So the first thing they ask themselves is, what chart can I show? When they should be asking themselves, what story can I tell? When I do workshops with clients, this comes up again and again. I'll assign a task, and teams immediately look at their data and start working on charts. They get busy working and forget to stop and think. Now, it's sort of good in a way, at least they're being visual, but I always remind them, take a step back. Think about the story first, which will always lead you to the right data, and then to the right visual approach. The second issue is that data people are so used to their data that they sometimes go into a kind of data haze. It's like snow blindness. There's so much data, and you fall so in love with a certain view of some really interesting data that you're overwhelmed by it. Your mission becomes, how can I use this amazing data, rather than thinking about why you're using it, and does it tell the story you're trying to tell? Essentially, you get hung up on exactly the data you have. You know exactly what you've measured, so you focus on how to visualize that. It's easy to get tunnel vision. Now, since you're probably a sophisticated and experienced data analyst, this likely works for you much of the time, but I frequently come across opportunities to change the thinking a bit. For example, I had a client investigating the link between R&D spending and the decline of a company over time. They had employee headcount and R&D spend as their two data values. And they planned to chart it all together in a chart like this with two axes. Blue is R&D spending, that's the left axis. Green is the employee headcount, and that's on the right axis. So, in addition to the fact that I would always work hard to avoid two-axis charts because they tend to be confusing, I thought there was a better way to get at the correlation that they wanted to show. I just suggested that they show the ratio between these two numbers, R&D spend per employee, as one line. Not only is it simpler, and probably half of you watching this had thought of that as soon as I said I looked at an alternative approach, but it also reveals that interesting spike in the data that the other two charts didn't show. Ratios and relationships often show interesting insights. The main point here is to always take the time and really think about your data. Think about your story. Think about whether the data you're illustrating really is the best data to show, or if there's something you can do with it to bring out the best of it for your story. Another problem is that you need to always remember to work hard to narrow down to just what's important. There's a lot going on in this slide, right? I see numbers, I see segmentation, I see callouts pointing to things. There's just a lot going on here. We're going to go through this in more detail later in Rethinking Charts, but what are we trying to actually communicate here? If we take the headline at face value, and the point is that the outlook for revenue growth is dim, we're really just concerned with 2014 and 2015 as far as the main point of this chart. So why are we going all the way back to 2002 with our data? Maybe there's a reason, or maybe we could have narrowed it to just 2008 plus, just telling the story of the post-recession. Visualizations are more than just data. They're more than just charts or maps. At best, they really are stories. If you think about it, from the dawn of time, humans have always communicated via story. Cavemen didn't come back from the hunt and have a spreadsheet to share how many arrows they used and how many miles they ran to chase down the game. They told a story. Their stories contained all the data, but it was told through narrative. And that's how the data was remembered and handed down generation to generation. There's a lot of brain science behind the fact that we're wired for story. Our brain's primary job is to contribute to our survival. It does this mostly by helping us understand what might happen in the future based on past events that we've experienced or that we've heard about through story. Effective stories reach us because they give us what the brain craves, a sense of urgency about what happens next, and a way to understand it so we can plan for and react to it if it happens again. So communicating data, like communicating anything, is about reaching your audience in a way that they can relate to. Stories really are the best way to do this. But that doesn't mean that every data visualization is a quote-unquote storytelling experience. But it does mean that the more you can use the structure of story, no matter how simple, the better off you'll be. Now, structure. Every story has a beginning, middle, and end. You remember this, right? Stories are simply linear sequences of things that flow in a logical, directional way. If you think of everything that you create as being in this context, even a single slide, the better off you'll be. Some stories have a more nuanced look, like this. There's a beginning, the challenge, the middle, the climax, etc. But really, beginning, middle, end is good enough to think about. Now, let's say you're creating a simple PowerPoint slide. First thing, you define the headline or title. You need to come up with great headlines before you even work on your project to really know what you're trying to communicate. Headlines help you focus and find your story. What's the next part of the story? There's an introduction. There's text maybe at the top of the slide to introduce the idea. It establishes the premise and the context before your reader dives into the data. The beginning is done. Now it's on to the challenge part of the story. So maybe the challenge is just a big subheader below the introductory text. Maybe this is really some bold type to draw the eye. My eye is going to go there, and this might be a good place to establish the surprise, the challenge in the story. The middle of the story is really the meat and the potatoes. So this is like the chart with all the details and the interactivity and the imagery where the user spends most of their time. How might we introduce the climax? This is a flowchart slide, let's say. This might be that climax moment. I'm really drawing the eye to it. The most interesting, surprising finding could be treated this way. Now, a couple of critical points here. First, your reader may not ingest your slide in this order. They may not read it in a predictable linear way at all. But if you use the structure of a linear story in your own mind, then the user can deconstruct that story if they want to. Second, and this is really key, I said the headline is the beginning of the story and the call-out text is the challenge, etc. That is absolutely not a rule. Sometimes the text of a slide is the conclusion, and the call-out might be the introduction. You get to decide where to put these elements and how you might want to guide your user through your story. The point is that the components have to all be there, so there's no confusion when people consume the content, because they expect story components even subconsciously, unless it's a very, very simple concept. If you're creating an interactive infographic, of course, you can literally walk them through a linear story by creating interactivity that makes the story come out. Or you can have all sorts of filtering and sorting buttons to really bring the story out in the order that you want to tell it. You can encourage the user to click certain filters first, and of course you can draw the eye to things when you want to draw the eye to them, either based on a click or a filter or some sort of user action. If we go back to our static example, it's also really easy to offer a conclusion, the end of our story on our slide. Maybe you have a small print footer with your data sources and some conclusion information. Structurally, it's very easy to see what the conclusion is in this infographic. If you think of every project you do, even nonlinear ones, even static graphics, within a linear The most important part of every news story is the headline. It's the attention grabber. It will entice your audience in to read more. And it's also the executive summary, the thesis that describes what your audience will hear more about. Without the headline, how do they know what to read? Remember the water cooler from my 4x4 model? This is the thing you need to provide to entice your reader to the next level, and it sets the stage for the main point of the piece. I find that when data analysts are creating charts, they tend to be too close to the data and forget the communications aspect of what they're doing, the big picture. They neglect their headlines in a variety of ways with many repercussions. The first mistake is neglecting to think of the headline first. We just discussed the importance of knowing your story, and really every story can be condensed into one headline. If you don't know your story, and specifically the one-line version of your story, how can you communicate it? So take the time to really think this through. Think of it like when your kid or spouse asks, "What's that movie about?" and you sum it up. You can probably sum up your data in one line, so take the time to do this. That's the bones of your headline, even if your first crack at it isn't perfect. The second mistake is not focusing on what's important. If you don't cover the important part, it's really not a headline. It won't attract an audience. It won't lead me to think that it's important. So you should capture the key idea, and your audience should agree that that's the important idea. So for instance, the headline for a news story about a hockey game probably shouldn't be referee's daughter got a C in math today, right? That's not going to entice me as a reader, and it's not really the most important part of the story, right? But this headline, Bruins thrash Canadians 6-1, I'm going to read that article, and this is probably the key part of the story. And by the way, if you're from Montreal, don't hate me. I'm from Boston. Don't hold it against me. Third mistake, you don't set up the story. So maybe you make a headline about one thing, but your chart is about another. So the headline is misleading. It's confusing to the reader and to the chart maker too. How to pick what to focus on. It should capture the key idea, not a sub-idea, and the chart should reflect that. So, back to my bad headline from before. Maybe the chart is all about the correlation between referees' mental state and how it affects their calls, in which case maybe this is what the story is about. Context and consistency are important. Fourth mistake, multiple headlines and subheads. How many charts have you seen, hopefully you haven't created too many yourself, where you have a header and a subheader and sub-subheaders and a chart title, etc.? It's so common. So here's a classic example. We have a slide header, we have a chart header, and we have a chart caption. Now, in this example, the caption is the actual headline. The outlook for revenue growth is dim. That's the interesting story here. Monthly revenues? That's an accurate label, maybe, but is that a headline? I don't think so. Revenues in the US, in US dollars by company division. Again, I guess that's probably accurate. It's a description, but neither of those top two things are the headline. So why is my eye drawn to the two things at the top? Those aren't the key points. Fifth mistake, lack of creativity and effort. You work for an organization that odds are is a serious place. You're going to be titling your slides and reports with straightforward, fact-driven information. But when coming up with your titles and headlines, don't forget your audience is made up of humans who would rather be entertained, even in a serious context. And you can have a lot of fun with a headline. Make sure it's audience appropriate, of course. But if you allow yourself to have some fun writing your headlines, even if you don't go quite as far as some of these examples, simply the act of thinking of the silly version will help you make your more serious one better. Let your creative juices flow, even if you end up pulling it back in the end. And just remember, your headlines and titles will help you focus and find your story and stick to No single short video can teach you what chart to use in every situation, but a lot of people have put thought into guidelines for how to pick the right chart for different types of data. You're not alone trying to figure this out. One example is the graphic continuum created by John Schwabish and Severina Rebecca. As you can see, what it's made up of is different categories of data types. So if you want to show the distribution of values, or values over time, or you want to compare things in categories, these are the types of visualization forms you might consider under these circumstances. For instance, how might I show a distribution of data? A histogram might be one of the choices available to me. And you see this connector line over here? A histogram uses columns to represent the distribution of data, it says. And so if I scroll over and down, I can see where that connects over here to this type of visualization in comparing categories. It connects to the column chart. So throughout this entire graphic, I can see connections between things, and it's a really handy reference to pick the right chart form for the right data type. And not just the right data type, but also what you want your audience to do with the data. If you want them to make comparisons, to understand change over time, to understand distribution, etc. One of the most important things that I recommend is that you try more than one. Try more than one visualization approach for every data set you're working with. Generate several charts and see which one says what you need to say about your data. Each visual will tell a different story. One of the other things I recommend is that you look for inspiration. And so I often go to the D3 website, d3js.org. And if you click on the examples link at the top of the page, it'll take you to this page where you can just see an endless array of different visualization styles. And so even if I'm not working in D3, I'll come here just to find inspiration of some really interesting visuals that I can try to recreate, either in D3 or in another tool. Another website that I look at frequently for inspiration is The Pudding, which does all kinds of really interesting data-driven stories. And so some of them, by the way, use very innovative, different ways of visualizing data. In this case, we're looking at comparing men's and women's pocket sizes in clothing. So it's not just charts and graphs. If you want to get really creative and find interesting ways of thinking about and communicating ideas like this, that's a great place to find inspiration. Another place to look, of course, is Reddit. They have the Data is Beautiful subreddit, which is just, endless stream of data visualizations with a focus on the quality of the data itself, not necessarily the visualizations, although, certainly are a lot of interesting visualizations on here as well. And there's also the subreddit called Data Art, which is more about the visual experience than the data itself. So between those two subreddits together, you can find a lot of really great and interesting work. Sometimes you can't beat vanilla. Bar charts are vanilla, but they're great. They really work very effectively for allowing your audience to make distinct value comparisons. And other times, your story, what you're trying to show, your data requires something more. In those cases, pick a visualization approach that matches your data and get inspired. Perhaps the most important consideration when making visualizations is deciding what you're actually doing. So you have some data, and you can show distribution or change over time or make comparisons. Okay, well, let's talk about comparisons. What are you comparing to? Are you comparing to an index, or last year's number, or the industry average, or the top 5% of performers in an industry, or something else? Picking the right chart for the data is a big subject. How do you pick the right chart for the data you have? You want to keep your audience interested. You might be worried about using quote-unquote boring charts. At the same time, there is a visual language and user experience reality you have to deal with. Your audience knows how to read and understand certain charts. Sometimes you want to give them something so easy, even a dog can understand it, right? Not to mention that if you have complex data, and whose data isn't more complex than you might think at first, then you often need to find new and unique ways to display that data. First things first, bar charts work really well. If your data works in a bar chart, use a bar chart. Humans can pre-attentively process and compare those rectangles very well. Remember, we talked about pre-attentive processing, that immediate ability to recognize and make judgments about visuals subconsciously. Your audience knows how to read bar charts, can make very good comparisons of values with them, so use them if they're appropriate for your data and the task at hand. Feel free to make them look nice, get creative with them, but use bar charts. Same thing goes with a line chart. If you're showing data over time, for example, a line chart's great. You can't beat it. Let's talk about a few other chart types that don't get enough play and that I think the world is ready to see more of. One is the slope graph. To show change over time, but focusing simply on a starting and ending point rather than showing every step along the way, this is an effective visual. You can see the total change, and the relative slope of the line is easy for people to understand. They're great for overlaying a lot of items together, and you can use contrasting color and thickness of the lines to really draw attention to just the one that matters. Allow the rest to fade back, but they're still there for context and comparison. So, for the example of time series data, here we have 20 years of data, and I've removed all the middle years because I don't need you to understand all the volatility. I only want you to understand where we started and where we ended. It's a good choice. Another chart family that I really would like to see used more are distribution diagrams. What you see here is, of course, a dot plot. You can overlay multiple points on a much tighter space, so it's really good for comparing a lot of things, where a grouped bar chart, as an example, would be completely overwhelming and useless. The beauty of distribution diagrams is you can get the gist of the overall data set and see individual data points, so you get the big picture and a detailed view. Another distribution diagram that I really love is the box plot. It doesn't get enough play outside of stock charts and scientific research papers, but where else can you put 5+ data points into such a compressed space? Not to mention leaving room to display outliers. If you have to show that range of values, quartiles and top and bottom percentiles and averages and outliers and all at the same time, it's really an efficient chart type to use. But, super important, this chart is really only useful for finance people and scientists, and it poses some serious issues in terms of pre-attentive processing. So, consider a variant, a simpler box plot. Forget the whiskers, right? Just showing minimum and maximum values, and maybe the median. Another type of data that can be difficult to work with is hierarchical data. And there are so many ways to show hierarchical data and different types of network graphs, but those can get really overwhelming, especially when there's a lot of data. I love this approach, the tree map. One of the reasons I love it is that it's rectangles. Remember, it's really easy for humans to parse rectangles and to compare how the area of one rectangle relates to the area of another rectangle. If you have lots of layers of data, you can add interactivity to a chart like this. So if I were to click into one of these boxes, it can zoom and reveal more rectangles within it, so that hierarchical information doesn't get lost, even though it can be greatly simplified using this visual approach. A tree map is a great way to show this type of data, and it's a great alternative for pie charts to simply show part-to-whole relationships. One more of my favorites is the connected scatterplot. It's just a scatterplot showing the relationship between two variables, and each dot is a year. Since there's a time component, you can connect the dots and show directionality. And now you're showing your audience not only the correlation between two variables, which is proven by research to be best shown in a scatterplot, by the way, but here you're also showing how that relationship has changed over time. And this chart does some really weird things because you can end up with things like loops, right? And lines going in the wrong direction, like right to left. We always think of times going the other way. For a sophisticated audience, or an audience with enough time and curiosity to dig into a visual to get it, this one might be worth trying. Another type of chart that you're seeing more and more, even used in newspapers, general audiences, is small multiples. Small multiples just means a collection of small charts. So you can see collections of line charts, or bar charts, or even small maps like these. And it's been proven by research that human beings are very good at comparing things like this when you have a bunch of small items all gathered together and next to each other. Color is incredibly powerful and equally as dangerous and difficult. It adds visual interest to your visualizations while potentially increasing readability of your data. But just as it can make it more readable and beautiful, color can just as easily make your visualization a hot mess. Following just a few simple rules can keep you from making a visual disaster. There's a lot of established thinking about how to use color in design, but you could spend plenty of time learning about how to combine colors and what colors mean and human psychology and cultural references. In fact, you can do some of that here on LinkedIn Learning. Anyway, the main thing you need to understand is that color is probably the hardest thing to learn. You might be able to learn it, but it's definitely not guaranteed. And unfortunately, many of the tools you use, yeah, I'm looking at you, Excel, they don't help because they use default color schemes that can lead you astray even before you blink. So, the first place to start, if you can, is to hire a great designer with a fantastic color sense to establish a color palette for you. If you work at a large corporation, odds are you have a color palette as part of your brand. Find the brand guidelines, spend an hour talking to your branding department, and learn how to use the colors. This is time well spent. Well, let's assume you can't do that, and you actually have to come up with your own palettes. One tool that I use is this site here, Adobe Color. It's simply a color wheel, and as you can see, it's just click and drag. You can drag these things around, and it will sort of create palettes, and you can follow rules. You can say, I want an analogous palette, or a monochromatic palette, or a triad palette. And you don't have to worry about exactly what these words mean. You can certainly study up on it and learn a little bit about it. But long story short, it will just develop different types of palettes for you. You can pull the hex colors or RGB values and use them in whatever tool you're using. Another tool that I use is this website, I Want Hue. And as you can see on the top right-hand corner here, Colors for Data Scientists generate and refine palettes of optimally distinct colors. And so you can see what I can do is then say, all right, I want a palette with 5 colors. And you can sort of choose what type of process to use, but don't worry about that. I'm going to click on Make a Palette, and it will generate a 5-color palette where the colors are optimally distinct from each other. And again, I can pull the values as JSON or CSS or whatever. But long story short, I can even make a 12-color palette. If you had to create that big of a palette, which, boy, you should try to avoid it if you can, but if you had to, this does a pretty darn good job of creating a palette that will be useful. Another tool that's referenced frequently in DataViz is Color Brewer, which is a great place to find palettes for use in mapping, but also charts more generally. And again, you can create sequential palettes, diverging palettes, qualitative palettes, and you can also make sure that they're colorblind safe. So a very useful tool for data visualization. One thing you really have to keep in mind is color blindness. So if you look at this image, all of these circles have numbers in the middle of them, and the vast majority of you listening to me right now can see those numbers. But 1 to 8% of you probably can't. The most common form of color blindness is called red-green color blindness, and people with this disability struggle to distinguish between red and green. So when you design a chart using red and green to indicate bad and good, be aware that those cues you're assuming will be instinctively understood may not be by a significant chunk of your audience. Another tool that can really help with color blindness is this website here, which has a color blindness simulator that allows you to upload an image, and you can actually test your image and see what people with different forms of color blindness will see. So you can really get a sense of whether or not your visualization will be accessible to those people. Another issue is, like in fashion, there is such a thing as too many colors. As I mentioned earlier, that 12-color palette, it's really hard for people to see that many colors and really parse them. So even if you're using a tool with good default colors, the next challenge is that there's a limit to how many you can distinguish before they start to blend together. So if you're using more than 5 to 7 colors, I usually say even 3 or 4, you really do risk confusing your audience. I've almost never seen a 10-color palette that was anything but overwhelming. Now, if you can do what you need to do with 1 to 3 colors, all the better. Less is more when it comes to color. So yeah, this chart is a great example. Just because Excel, for instance, tries to assign a color to every single thing, just because you can use many colors doesn't mean that you should. Only use color to express something, to make variations stand out, to categorize things that need categorizing. Use as simple and minimal a palette as possible. And so, for instance, here's that same chart. I've eliminated almost all of the colors. I'm only focusing the eye on the things that matter. For instance, the year 2014 is when this chart was created, and there are these scenarios for what was going to happen in 2015. So I used color to really point those out. The short version of my Every show has a star, and the star in your data visualizations are the data, not the supporting characters. But every show relies on its supporting characters, and so too are they critical to a successful visualization of your data. When I'm teaching beginners to data visualization about axes and labels and legends, I focus on reminding them to include them. I talk about how important it is to channel the novice, to provide enough information to guide the audience to what's important in the data. I often reference the Zen Buddhist practice of finding your beginner's mind. Remember what it was like to not know anything, so you know what guideposts to provide your audience to help them navigate the data. But when speaking to data analysts, the opposite is usually the concern. They fall in love with their data. They feel that every bit of data is incredibly important. Nothing can be left out, or it'll feel dishonest at worst, or incomplete at best, right? You need to resist this temptation, and remember, the point of labeling is to help your user understand what's important. And if you ask them to focus on everything, they can't focus on anything. First, let's talk about the legends or keys to visualizations. The first thing I recommend is that when you're creating a visualization, whenever possible, don't stick your key over there in the corner. This is something that the software you use probably does by default, and like many things your software does by default, it's not always the best solution. You should always, if possible, put your keys in line in your content. Use color and positioning as the cue that helps your users understand what means what. Sometimes you need more than just a simple legend. This is a project that I made on hospital pricing, and there's a lot going on here. There are these bars with different colors and different positioning, and as you click into things, you see more stuff, scatter plots, I can sort things, all kinds of things going on. And a sophisticated user could probably figure out how to use this and what exactly is happening. But more of a beginner might struggle. And so what I always do in this case for something more complex is I create a very detailed how to read this chart type of explanation. So I have a literal visual representation of what the screen is showing you, little connector lines, and descriptions of what every single bit means in detail. Again, really tapping into that beginner's mind and what they need to understand to know what's going on here. Here's another project I did, which is another issue that always comes up in data visualization. The default in most of our software, whatever you're using, is to create axis labels, like the numbers on the axes on a chart, in high contrast black. And so in this case, I made them very light gray so that as you're scrolling through this data story that I created, the highlights are visible. Everything becomes more visible because the axis lines and the axis labels fade back. They get out of the way. That's really important. Finally, think about how you label your data. This is really the biggest thing I see data analysts struggle with. They just want to label everything. Of all people probably know the basic rules about how to think about scale and data visualization, but I'm going to repeat them here because I've had some debates, even with very experienced data people, about the most basic rule of them all. And the reason the rule is so important is because of those Gestalt principles that we talked about earlier. So to start, I'm going to share a few charts, all right? So here's a chart. This is a company's sales figures for its 6 regions. So A is doing definitely the best, B is doing pretty well, and then C, D, E, and F, yeah, they're doing okay, but they're certainly not doing as well as the others. Here's another company, also has 6 regions, and wow, all 6 regions are doing very poorly. And yeah, I guess A is the best, but not so hot. And finally, we have this last company. A is killing it, B is close behind, and the rest are doing poorly, especially F, who has barely sold anything, right? So you're all data analysts who are watching this course, and of course, you probably quickly saw that these are all the same chart, the same company, just with different scales. And of course, the title of this presentation probably helped give that away. But in any case, what's the problem here? The main problem is that rule, the most important rule of all, which is you must never, ever, 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 and I really mean that, ever, ever, ever start a bar chart or a column chart at any value other than 0. If you've heard this, and if you agree with it completely and you know why it is, please feel free to skip ahead. But if you have any qualms, hear me out. The main reason is this. Humans are really good at reading the sizes of rectangles. And the nature of a bar chart is that the height of the rectangle is telling you something. It directly represents the value. But it's not just the height. It's actually the fact that as humans, we immediately interpret the area of the rectangle. We may not know we're doing that, but that's what we're actually thinking of. Subconsciously, we're measuring the area. So the height times width is the area. So it's sort of about the height, but the fact of the matter is, it's really about the area. So in this chart, F looks like it's sold nothing. And even if I see the 100 on the scale, right, we didn't start at 0, even if I'm sophisticated and I understand that the scale is cut off, it looks like F has sold nothing. And it's really hard to undo the damage that my pre-attentive response to this chart has done. So I've had clients argue with me on this one. They say, if I start the scale at 0 though, it's too hard to see the difference between these bars. So what's the answer when that's the situation? Well, maybe it's obvious to some of you. Just chart the difference instead of the values themselves. If that's the story, show that, and there are plenty of charts to show variance. Okay, but you insist you have to show the actual numbers, not the change. This is what I was saying before, dot plot, right? You can just have little lines or little dots. Feel free to do it this way, just don't use bars. Many other chart forms are okay to use with different y-axes, different y-scales. So see this line chart. It's okay that the bottom starts at some number other than 0. I'm looking at the trend of the line over time, not the area. It's not the area of a line that matters, so a non-zero starting point is fine in this case. Now, an area chart works more like a bar chart. The area, as the name implies, means that it's the area that matters. So you have to start a chart like this at 0. Starting an area chart with a non-zero scale has the same opportunity for misrepresentation. How about another major issue with scale? What about pushing the top end of the scale up? This poses a different problem. So right now we're emphasizing how little each division has sold. If our scale is intentional because we have a much higher target that they're supposed to be hitting, then that's fine. So this company, maybe they have a target at 1600 and no one's even close to hitting it. Okay, they are failing, right? Then it's okay to use this scale. But if we're using this scale just because we're trying to manipulate our audience to feel that the numbers are too low, that's a problem. And this gets to one of the biggest issues with setting the scale for a visualization. There's a lot of room for disingenuousness and downright dishonesty with scales. Be fair and accurate with your scales. Another rule I follow religiously, though I can occasionally be convinced of exceptions, is to use round numbers. A lot of software we use will kick out a chart and set the scales for us. So sometimes it'll pick the best numbers from an accuracy standpoint, but they're not human. They're not accessible. Your audience will always appreciate more accessible, round, memorable numbers. So this chart, instead of starting at 4472 and going up to 10,472, it should be 4,500 and 10,500 or 5,000 and 10,000. Stick with those. And while you're at it, why show all those numbers on the y-axis? Who cares about 6,500 or 8,500, or really just about all of them? Maybe you can get away with just showing the top and bottom numbers. If you do need to show more, if you can make a case to use them, go for it. But by default, there should be less, not more. Another rule people sometimes forget is that when working outside of software that automatically creates visualizations for you, so maybe you're creating your graphic in Photoshop or Illustrator, or you're programming something in Python or D3, you need to decide how to create your shapes and set the parameters manually. So this becomes really important when thinking about a bunch of non-rectangular shapes especially. For instance, circles. With circles, you don't want to double the diameter or double the radius, because if you remember your elementary school math, the equation for a circle is pi r squared. If you double the diameter to mean double the value, you're really changing the meaning of that circle in crazy ways. Just be careful. Finally, there's logarithmic scales. Sometimes you have very large values in your data, and your chart will get difficult to read because a few things maybe are at one end of a spectrum and maybe the rest are at the other end. Or maybe because sometimes a log scale is the best way to show rate of change over time. This can be visually confusing without a logarithmic scale. So this is a valid visualization technique and not something you should avoid. However, you need to be very careful in notating your charts clearly when using a logarithmic scale, especially if your audience is made up of unsophisticated chart readers. Many people are unsure when to use log scales, when it's fair and right, and when it can be confusing or potentially skew your audience's understanding of the data. Another use case for using log scales is when dealing with exponential growth. This chart is logging something that's increasing exponentially over time. The values go up very slowly, and then all of a sudden it goes like a hockey stick. That's if we show it on a linear scale, as on the left here, where the values on the y-axis increment by addition. But on a log scale, where the values increment by multiplication, it looks like this one on the right. You're a data analyst. You have your tools. You're probably working in SPSS or Stata or R or whatever. You're working in tools that are built for your data, right? But you may or may not be working in tools built to make beautiful and simple graphic displays of that data. In this movie, I'm going to talk briefly about tools and how to use them and think about them, as well as to try to introduce you to some tools and functionality that you may or may not be aware of. First, let's talk about the standbys that you're likely using. Whether you're in Excel, Stata, SPSS, or another tool, you can and probably already do generate your own charts and graphs. This is what you do all day long, right? Okay, but here's the thing. Many of those tools by default don't follow the rules I'm laying out for how to design effective charts and graphs. The default colors tend to be overwhelming, the axes are overemphasized, etc., etc., etc. However, in most, if not all of these tools, you can format your charts to do what I'm suggesting. And some of these tools have the ability to load in styles or templates. So if the tool you use can do this, that's great. Just create a chart, apply the styles and formats that work according to best practices, save those settings, and then you can easily apply those styles to future charts of that type. So don't tell me your tools can't do what I'm recommending. The odds are against it. That being said, every software tool is limited in what it can produce, unless you're coding from scratch. You're always going to be trading flexibility for speed when using tools like this. So let's assume you want to push your designs a bit further, or you want to use a chart type that's not available in your tool of choice. Many data analysts won't abandon their tool. Conversation over. I'm not listening, right? But if you're willing to consider it, there's a huge selection of tools available to you to work with. For instance, here's a website I go to sometimes when I need to find a tool to do a specific thing. And you can see the way it's organized. I have every tool across the horizontal, and then I have all the different types of things I might want to do on the vertical. So let's say I decided that I wanted to create a word cloud or a proportional shape chart. I can just sort of go across and figure out whether different tools will do it, and in fact, find links to specific examples. So for instance, D3, I can click through and literally see an example of this being done in D3. So very helpful to find tools to do specific things. And speaking of D3 is a fantastic tool. If you know how to program or are willing to learn how to program, D3 is a JavaScript library for creating really sexy, cool, animated, interactive visualizations. So I highly recommend D3 if you're able to do programming. And there are a bunch of other tools that are sort of newer to the scene in relative terms. And there are a few of them I want to just show you very briefly. Raw Graphs, which is a cloud-based tool. You upload your data and you can very quickly and easily generate a variety of types of charts, embed them into a website, or export an image or a PDF, I believe, for use in print reports and the like. A very similar tool is called Data Wrapper, also cloud-based. Upload your data, create charts and graphs, etc. Very easy to use. Both of these tools, click and drag. You can do various levels of styling across both of these tools. Really powerful and easy to use tools to make sophisticated visualizations with highly nuanced styling and notation, and a lot of things that aren't available in tools like Excel, for example. A newer competitor to both of those tools is something called Vislo, which is kind of interesting in that, just like them, is a cloud-based tool. You upload your data, you can make cool stuff easily, quickly, etc. But the exciting thing about Vislo is they also have a desktop version. So if you're not allowed to upload your proprietary data to the cloud, which many organizations can't do, you can actually use this locally, which is kind of great. And then finally, just a nice tool to keep in mind is Carto. For many people, maps are like a whole nother category, and they're really hard to make if you don't have the right tool set, if you don't have experience in making them. Carto makes it really easy to make amazingly cool maps. It's click and drag, cloud-based interface, upload your data, follow a couple of wizards, and you can make incredible. Sketching and wireframing is one of the first things you should do in your visualization process. It's really important. But it's also the thing that data analysts are probably most reluctant to do. Does this sound familiar? You have some data, you do some analysis, and your analysis includes looking at the data in a few different charts. So you use visualization as part of your analysis process. By the way, that's a very good thing. I'm sure you all agree that visualization is a critical part of the analysis itself. Maybe you already know about Anscombe's quartet. Francis Anscombe was an English statistician who took 4 datasets with nearly identical properties. Each had 11 data points, the same mean and variance of both x and y, the same correlation between x and y, as well as the same regression line. But as you can see, by visualizing them, you can easily see how drastically different they are. This was a bit of a tangent, but let's go back to where we left off. You're doing visualization as part of your analysis. That's good. So you finally found the chart that shows an insight. But now what do? You know you need to make a PowerPoint slide about this, so you export that chart and put it into PowerPoint and you're done, right? I'm sure that is right, meaning I bet that's how you tend to do it. but I'm going to suggest that that's entirely wrong. You need to do what I suggested at the beginning of this section of the course. First, you need to come up with a story for that slide. What are you trying to explain? What's the beginning, middle, and end? What's the logic? Then think about your headlines. So in this example, there's a positive correlation up to a certain point, at which point you get diminishing returns, and the correlation reverses. So, something interesting is happening when X reaches 11. Aha. So our headline could be correlation reverses and accelerates downward after 11. This is sort of like a old school traditional newspaper version of your headline, very literal and completely uninspiring. Maybe a little bit more fun. How about this? What goes up must come down, ... after 11. That makes a better headline, right? It's just a little bit more entertaining. Or a totally tabloid version of the headline, 11 is a bad seed, right? Just a little bit more dramatic. Once you know your story and you've chosen the perfect title for the slide, now I want you to sketch some ideas. So you might ask yourself, why on earth would I do that when I have a perfectly good chart that I just created? The reason is you created your chart without the benefit of a story or a headline. That's what we've been talking about. Yes, your chart may work for you. It helped you see something, but there might be another chart that communicates that insight more effectively for your audience. So consider alternatives. There's always more than one way to show your data, as you well know. For instance, maybe just showing a slope graph of the change and the values could do the trick. And by the way, I created this using an unresponsive digital tablet using Photoshop. It's an ugly, hot mess, right? But that's okay. It helps me get to an idea very, very quickly. So back to the chart. I actually like this chart type for certain uses. I might have chosen this approach for this chart after making this sketch, and I would probably look at other options and sketch those quickly as well. But let's assume you do stick with that original chart type. Use that as your starting point for your sketch. Print it out, start writing on it, or just sketch a mock-up of it and riff on it. Just a messy, ugly thing like this one here. This takes 10 seconds to create. So start working with it. For instance, can you think about how you would annotate your chart differently to highlight the so what? Maybe you add interesting callouts for your audience. And by the way, that text there says, something is happening here, in case you can't read my terrible handwriting. Can a background color for part of the chart or a segmentation line help communicate what you need to say? Spending literally 5 to 10 minutes sketching out your chart in the context of your story and headline will always result in a better visual depiction of the data. Maybe you can only do this for your most important charts in a presentation. I know time is scarce, but it's well worth it if you care about how you're communicating your brilliant data analysis. Again, this is about very quickly and easily validating ideas, seeing if you can bring eyes and your audience's attention to what's important. Then you can worry about how you can execute on it in your tool of choice. And by the way, as I mention a lot in all of my courses, I believe strongly that when I say sketching, I mean you should sketch on paper or on a whiteboard. As I always say, when in doubt, just do less. Show less detail, use less information, edit, remove, simplify. But without exception, the excuse I always hear, especially from my data analyst clients, is that they have to show all the data. Sometimes it's because they feel they need to back up every point they're making with minutia and details, and I can usually get them past that argument. But I never win the next most common argument, which is that the PowerPoint or the PDF they're creating is a leave behind, not just speaker support for a meeting. And this is a fair point. If you're creating a leave behind, so you won't be there to walk the audience through the data, then yes, you may have to include more details. But, and this is critical, that does not give you carte blanche to put every detail back in that I might have just started to convince you should come out. You should still work hard to critically approach your decisions and only include what you must include, even within that reality. It doesn't have to be a mile deep. Also, if you're presenting your findings and then leaving a leave behind, then create 2 versions of your presentation. The first version is the one you'll present, and the second is the leave behind. This isn't as much work as it sounds. You start with the more detailed version, and then you strip things out for the less detailed version. Think of this more detailed version like your engineer's spec version. Everything may be important, so include it if you must. So, like in this spec diagram here, you need all these measurements, right? The engineers need this stuff. But you save a copy, that's for the presentation, and you do your editing and slimming down in that version. You only include the top most important detail for this version that you're going to present. The main point for my presentation on this is that one number, 119. All the rest of it in that previous version is just noise. And of course, you can also use builds. Let's say you're creating a PowerPoint. You create your hopefully not too cluttered slide with more detail that's hidden in a build of that slide that won't appear until a mouse click. This way you can present the simpler version. So you're probably thinking to yourself, isn't this a course on data visualization? Why are you talking about text-based slides? Well, here's the thing. Presenting information is presenting information, whether in data or in text, whether charts and graphs or in paragraphs. You're presenting information all the time. And while we're here talking about data, I thought it was worth a few minutes to talk about the rest of your presentation too. Don't skip this movie. I do think you'll learn something from it. And by the way, one of these two so-called text-based slides is really a data slide. Yes, the same principles apply, of course. Know your story. Pick great headlines. Know what you really want to say. Do less, etc. So here's the first of two examples. This is a report from the President's Council of Economic Advisors reporting on the state of the economy back in 2014. This, believe it or not, is the opening slide in that presentation. Right? Can't you see the overarching story? Do you get what's important? No, neither do I. Okay, so let's redesign this thing. Now, I'm a busy guy, so I only have a couple minutes to redesign, not enough time to do anything significant. How about we at least break it into two slides? First progress, then challenges. The two separate ideas deserve two slides, but of course, I would go further than that. These two slides may have separate ideas even on each of them. First, I removed the word overview from the top. It's wasted space. It's a wasted idea. It's clear that this is an overview report. The title already implies that. So I added jobs as a big subhead on the right at the top there. That's going to change from slide to slide. For now, I'm still leaving the main point here in sentence form. By November, 2014 was already the best year of job growth since 1999. It's still a sentence, but by using a little bit of typography to call out the important stuff, my eye is drawn to the big red text. I get it. Since 1999, the best year of job growth. Now, the second bullet from the original was about wages. So I changed the word in the upper right for this slide to wages. Now we're on to a new subject matter, and the two key ideas in this category rise to the top with one big idea that really pops. We're exceeding expectations. Now, another approach, of course, is just to abandon sentences and go to bullets, keywords. Job growth from higher paying industries. We don't need it to be in sentence form. We can just make it bullet-like. We're highly emphasizing the key points here. This doesn't require design skills. It's just strategically edited and a little bit of color. You can do this. All right, let's look at the second example. This is also an actual slide from a NASA presentation that I found on SlideShare about Mars exploration. If you read this slide, it's really interesting. There's a lot of information, and there's even a bit of data. You have these 3-letter project abbreviation lists after each bullet. Those indicate which Mars exploration project led to these various discoveries. But as a slide, it's way too dense. It's terrible for speaker support since the audience will be reading rather than listening, probably like you're doing right now. And there's nothing drawing my eye to anything or organizing the information. So I took the liberty of doing a quick redesign. So we have our headline, A Decade of Discoveries, and a little subhead, or actually really sort of a continuation of the headline. It reveals a diverse planet with a complex history. I have bullets capturing the key ideas with details to follow. So diverse mineralogy, it's a wet, warm climate, pervasive water ice, climate change, etc. And then details below each one. If you want to read the details, you can, but you're not forced to, unlike the prior version of this. So the highlight really draws the eye, and all the information is much less overwhelming, more organized, and more compelling. And of course, I can immediately see Now I'm going to share a bunch of examples of charts and show you the originals pretty much as I found them, and then walk through how I redesigned them, applying the principles we've been talking about for the entire course. I know you're probably getting tired of hearing me say it, but it's important. The main point here is to simplify, to do less, to know what you really want to say, and make sure you really draw focus there. So here we have a chart. The scenario here is we have, let's say, data from two companies. One's a manufacturer and one's a retailer, and they've agreed to sell the products at a certain price. The retailer is trying to make the point that when they are under contract to sell the product at a certain price, they adhered to those rules. And when they weren't under contract to do so, they actually adhered at an even higher rate. So they were doing a good job even though they weren't being forced to. Make sense? The redesign is just much simpler and takes out a lot of visual noise. And also it follows all of the other things that I always say to do. My axes are now gray instead of black. You'll notice I also took almost all of the numbers out of the axes because who cares about where 20%, 40%, or 60% are, as we see in the original. The point on this one is the trend line overall, the shape of the lines, the positions next to each other. It's not about the specific locations of things. You'll also notice I moved the y-axis label, cumulative percentage of skews. Don't make your audience rotate their heads 90 degrees to read your axes. I moved it up to the top, renamed it more simply to 100% of skews, parentheses cumulative, combining the axis label and the number itself. You'll also notice I took out those two big arrows. They're not really helping me understand. I understand that higher adherence is to the upper left and lower adherence is to the bottom right. That's well worth highlighting, but the arrows don't really help me. They're visual clutter. I did make those labels nice and bold, but not too bold. They're still gray so as not to draw too much focus, but all caps helps them stand out a bit. You'll also notice I got rid of that grid. If I don't need those hash marks and those percentages on my axes, do I really need the grid to point out where those lines cross each other somewhere in the middle of that chart? I don't think so. And finally, in the original, you notice that we have a key at the bottom, which, as I've said before, when you can avoid it, don't put your keys at the bottom or on the side where someone has to look back and forth to figure out what they're looking at. Just put the keys in line as I've done here. Outside agreement is in the same color as the line it represents, and it's right next to it. So here's another example. Here I have manufacturing cost advantage. You see different brands of some kind of a machine, and the idea is that the more pieces you produce using this machine, the cheaper it is. Makes sense. You'll notice that we have a logarithmic scale. In my redesign, I didn't touch that. I'm assuming that the logarithmic scale is an important part of this, and I can see how that would be important in a case like this, and I'm also going to assume that the audience won't be confused by that. So here's my redesign. Really quick. I kept the scale, but I took out all the hash marks. They're not really visually helpful from any standpoint. You'll notice I also took some other liberties. In the original, each line was a different brand in a different color. Everyone was listed. Each line had little markers, the shapes. So I could easily follow which line I'm looking at, right? Well, you know what? I couldn't easily follow it. It's actually completely confusing. So I made a leap of faith here and I said, you know what? They probably don't need to compare all 12 brands. I'm guessing really it's a couple of categories of machines that need to be singled out and a couple colors, a couple shades of gray to highlight those two categories. But the main focus is on two key machines. Those are the companies that we actually care about. That's the point of this data story. So two bright, colorized, thicker lines to really draw the eye, and everything else is simplified and faded back to a large degree. Here's this example, which we've seen in earlier movies in this course. This thing's a total mess. I hate it, but I love it. I love to hate it. There's so many colors, so many segments, different scales of color, different meanings of color, call-outs, multiple titles. I mean, everything that can go wrong did go wrong here, right? So my redesign is very, very simple, and I've already talked about it a little bit, so very briefly, the title at the top is the headline. The outlook for revenue growth is dim, which means knowing that this data came from 2014, the point is about 2014 to 2015, so everything else is grayed out. You could make the case I could have removed it, but I didn't. But certainly a debate that you could have. What's my eye drawn to? That negative 2%. What happened from 2013 to 2014? Okay. But the color also highlights this year in one color, and then the scenarios, base, bear, and bull, for next year. And those are called out. And so my eye is drawn there. I'm getting the story, and everything is sort of emphasized or de-emphasized very strategically. Here's another example. This is a chart from a government report. So what are we looking at here? Mean GDP growth. Once again, I don't have a problem with the chart selection in this case. I don't even have a problem with most of the components of this chart, even that background gray rectangle, to indicate a recession period, which is a standard approach.
What I don't like about this chart are those big, honking, thick diamond shapes and the thick lines, and the fact that everything is sort of overwhelming. Plus, labeling every single data point on the chart, not to mention the box and whiskers chart. Those dotted extending lines and the little hash marks at the top and bottom, they're a standard approach to this chart type, but they really are a design disaster. So one approach to the redesign, this uses a lot of blue. Maybe it's too much blue, including the axis labels, but taking everything and just sort of simplifying the shapes. Shrunk down those average middle points, the median GDP growth number, those little dots. It's just visually simplified. I also added an overall mean as a little dotted line across, so it's not like I took everything away. Here's another approach to the same chart. Maybe the idea here was to actually call out a couple of numbers. Fine. I'm not opposed to labeling things. In fact, the opposite. Label what needs to be labeled. Just don't label everything. You'll notice in this example, I've also removed that blue outline around the recession period. And as I mentioned before, in this case, the axes are gray instead of blue. And look how much simpler this all feels. In this case, I also do have a key in the upper right-hand corner. I really couldn't find a way to put a key in line very effectively. Sometimes that's okay. You got to do what you got to do sometimes. And a third approach. Let's say you've convinced me you have to label everything. It's a government report. The detail is required. Sometimes you can convince me of this, although pretty rarely. But if the argument is really strong, okay, label everything. But maybe do it in a way that's visually appealing, that's not too overwhelming. And maybe you can stick with my version and just put a table of numbers in the appendix. I find it hard to believe that solution won't work 99.999% of the time. And another example. If you look at this closely, we have inline labeling, right? So consumption to DPI ratio is in green, total wealth to DPI ratio is in pink, just like the lines they're aligned with, perfect. Unfortunately, they also did was they tell us which axis to look at in that legend in line. That's confusing, right? There are two axes. There's a lot of text going on in the middle. It's visually confusing because of all those recession period gray background lines. It's pretty overwhelming, even though it does a couple things right. So I took this one and, can you guess, simplified it. I took some liberties. First of all, those recession background shades I dimmed way back. You probably need them, but let's not make them quite so distracting, quite so high contrast. But the main thing I did here is I split this into two charts. I don't want to have one axis on the left and one on the right, and the labels to tell which is which. How about two different charts? I can see them on top of each other. I can still compare the shapes of these lines to each other. And my last example. Here we have a very complicated chart to look at, and the explanation for it is in the text below the chart. If 5% of the addressable market uses this machine, platform A, and they each use that for 30% of the year, these manufacturers would produce 2.4 times the current output for this subcategory, 20% of the total market for the category. So the point here is where that red line crosses that hash mark at 20% on the y-axis and 30% on the x-axis. Okay, I get it. It took me a long time to understand this chart, but once I got it and decided to redesign it, I came up with a couple of different approaches. And by the way, quick note, sometimes the data and the story is complicated and it's going to be hard to figure it out. That's okay. Sometimes the world is difficult, so we can't solve all problems in this way. But I can still redesign it and make it better. So here's one idea. You'll notice I bolded the line for that 5% of addressable market. This is the line we're focusing on. And I took out that big honking orange arrow pointing at my text and connecting that line to my text. I don't need to do that because using color, everything is gray except the things in orange that I'm drawing your eye to. I'm making it clear that the 20% and 30% axis points and that point where they meet is the scenario being described. I'm reinforcing that by even colorizing the labels on the axes themselves. You'll also notice that I took that right-hand number, the growth percentages, and put them as parentheses within the left-hand axis. So it's market share and output growth sort of put together. You might say that's weird, and you'd be right, but sometimes you try things and see if they'll fly. Like my subject matter expert on this might tell me I can't do that, or maybe it's totally fine to do that. Now, in this case, I actually added to the grid. We had a grid of lines across from the y-axis, horizontal grid lines, in the original, but the point here is where both lines cross. So I added a grid for the y-axis values as well. So I grade it way back, right? It's very in this course around simplifying and focusing your audience, and you like the examples I've been showing. You're all psyched up and you're ready to go and show your boss and your clients these fantastic new simpler visualizations you're creating. The first thing that's going to happen is that they might make all the same arguments you may have been thinking at the beginning of this course. They'll make all the usual excuses for more cluttered, more complex, harder to understand charts and graphs. First, let me say this: you will lose many of these battles. As I always say, my clients pay me to tell them no once. I'll make the right arguments, I'll defend my position, and I'll ask them if they're sure they want to do what I don't think they should do. Actually, I'll even do it more than once, usually a few times. But in the end, it's their company, it's their project, and they're paying me for my help, not to tell them what to do. When your boss makes the decisions, you have to understand all the reasons they say no. These are the various facial expressions you might see and what they mean. The primary motivator is almost always fear. They're worried about what their bosses will say. Don't forget that. This boss needs expertise and data and rational reasons for your arguments. This is Mr. Skeptical. He heard your rational reasons and just won't believe it, right? He might need to hear case studies and more proof points. This boss is simply jaded to the entire process and thinks you're hilarious for trying something new. For him, you have to laugh along and note that you're playing the same game too. You get that this might fail, but are willing to take a chance on it, and he should too. She's overwhelmed by too many other things to deal with, by the number of people she'll need to help convince, the overly technical nature of the ask, etc. You need to calm her with a clear plan of attack for supporting her through this process. This is Mr. Impossible. He might not be convinced at all, no matter what you say. But our portfolio approach of arguments used for all the other personas is the best thing you can bring to bear against this guy. So just do your best, make your case, and hope that your message makes it through. Given all of this, I have some specific ideas to share with you. So your boss just put the kibosh in your plans. What's the first thing to do? Do you slink back to your desk, tail between your legs, and undo all those wonderful edits you made to your visualization? No. You ask why. You don't slink and you don't argue. You're the empathetic professional. All you have to do is say exactly this: I completely understand. We need to get a lot of detail to your audience, but I think I have another approach I'd like to recommend. Do you have 5 minutes to discuss it? Your empathetic approach will put your boss or client at ease, and he or she will be curious to hear more. Note that I said recommend and not try. You're not experimenting. You know what you're doing. You're making smart recommendations. You're actually like a coach with a plan. Another thing to consider is that your boss may not perceive you as an expert on the subject, but by leveraging the expertise of people in the field, you can bask in their glow of expertise. You need 1 or 2 statistics or facts to pull out to make the case for simplicity. Tell me this guy doesn't have some serious expert glow to benefit from, right? Your boss will definitely believe it if he says it. So, 2 great facts to share. Humans can only hold around 4 items in short-term memory for 20 to 30 seconds. This is scientifically tested psychology. So a chart with dozens of labels and callouts and details is really not useful from a presentation standpoint. One of the most common reasons we forget things is because of something called interference, the competition between different ideas struggling to be captured in our brains. A busy chart creates more interference, reducing understanding and memory. Now, another approach is you can always blame kids these days, meaning you can point out that as time rolls on, we're more and more distracted by data, by demands on our time, by our electronic devices, by advertisers. People are exposed to 15.5 hours of consumable media per day. Your chart has to make it through the clutter to be seen even by an otherwise attentive audience. It's also worth remembering that it's much easier to sell someone one thing at a time. So think about when you want to buy a car. You start out all happy when you get to the dealership. Maybe the sales guy isn't too sleazy, the cars are shiny, and you just want the car. You make a deal, and then you get passed off to the finance guy. And now suddenly he's talking about all those extra things to add onto the car. It's frustrating. You get annoyed because you're being sold too many things at once. Sell your audience the car on its own. You can weave a more complex sale together, starting with a car, and then moving on to the sunroof, leather seats, etc. But make the deal for the car first. Use this metaphor with your boss. You want to show one thing in your chart. Then add more pages to your presentation to layer more details on top of that. It's also proven by all kinds of research that humans are wired for visual communication. 1 million text labels and callouts and a lack of white space isn't just ugly, it's bad communications. This is all heavily researched and backed by brain science and studies galore. There's a reason that books have margins and that newspaper visuals are extremely simple, and that USA Today began printing simple charts and graphs back in the 80s. We're wired to see data, not to read it. So a simpler graph with less detail will do a better job communicating than a table full of numbers or even a heavily labeled chart. And never forget to keep pushing, to force answers to the whys. What are you really trying to say? What is the data saying? And what does your audience need to hear? Your boss or client is always trying to say something, even though they may not consciously feel that way sometimes. They just want to include everything, right? But they do have an agenda. If you can remind them of this by asking these questions, asking them to sum up the headline for the chart, you might win the argument. And if the answer they give is too vague or broad, just keep adding, meaning what or why. You can usually ask enough questions, just ask why and why and why again. You can usually whittle just about anything down to one key idea or point. And don't forget to offer to do more than one version, one for the leave behind and one for the presentation. That will usually win the argument. But wait a second. You just promised to do more work. That's no fun. But I know you're willing to. Data visualization is about communicating. And for data analysts who are neck deep in data, it can sometimes be hard to separate from the data itself and think just about the communications of the stories behind the data. I hope this course has helped you think a bit about the storytelling and that it's helped you think more strategically about how to communicate that information in a visual way that'll connect with your audience. In addition to this basic course on the subject, there are a lot of great resources out there that I'd like to recommend to any data visualization enthusiast. First, follow me here on LinkedIn or Twitter. I share a lot of data visualization content, inspirational examples, research, thought leadership, my own musings and advice on the subject, etc. And consider joining the Data Visualization Society, which was formed in 2019 and has many thousands of members from around the world. There's a very active Slack channel with conversations about events, freelancing, philosophical topics, specific tools, and much, much more. You can find people just like you on there and people not at all like you, which is great. And by the way, I'm on the board of directors for DVS. I really believe in this organization. DVS also has a great, fantastic publication on Medium called Nightingale, which provides a steady supply of thought leadership covering a broad range of topics that you'll find interesting and educational. There are also, of course, plenty of books on the subject, including some of my favorites like The Functional Art, Now You See It, Visualize This, and History of Information Graphics. And these are some of the publications that I look to most often for the most inspirational and consistent work being done in data visualization and storytelling. You can always go to these sites to find great inspirations for simple charts and compelling visualizations of very complex ideas. They have assembled amazing teams of people working in this very interesting field. I hope you've enjoyed this course. I had a blast putting all these thoughts and materials together. I really hope to meet some of you out in the real world, and I wish you all very good luck and happy experiences visualizing data.